America has been sold a comforting myth that charging is just building more stations. But the real war is happening inside the truck at the voltage level, where physics doesn't care about slogans. Most electric pickups in the US still live in a 400-volt world, and when you demand gas station speed from a 400-volt system, you pay in one current. More amps, more heat, more throttling, more waiting. Meanwhile, a different class of EVs is quietly normalizing 800 volts behavior charging at higher voltage, so the same power can flow with less current stress. Tesla's Cybertruck, for example, runs a nominal 800-volt pack and can reconfigure for 400-volt compatibility, a clue that even the US already knows what comes next. If this becomes the baseline, the risk isn't just slower road trips. It's that America's electric truck boom turns into a trap built on an architecture that can't scale to the refuel speed people will soon expect. For a century, America built its freedom around one assumption: refueling is instant. A pickup could cross states like it was crossing neighborhoods. Stop for 5 minutes, fill the tank. Keep moving. That expectation isn't consumer entitlement. It's the operating system of US truck life work sites. Tow rigs, winter commutes, rural miles. So when EV trucks arrived, Detroit tried to keep the story familiar. Same truck, different fuel. But electricity doesn't play by gas station rules. Charging is not pouring energy. It's negotiating heat voltage current and battery safety every single time. And here's the key detail most people missed. Ford built the F-150 Lightning on a 400-volt battery architecture. That choice isn't automatically wrong. It's practical proven and cheaper to industrialize. But it also means the US EV pickup revolution was launched with a built-in ceiling to chase high charging power at 400 volts. You need extremely high current, and high current is where cables get heavy, stations get stressed, and batteries start protecting themselves by throttling. Meanwhile, other players normalized an alternate path: 800-volt charging behavior, high voltage, lower current stress for the same power. Hyundai's EGMP platform made 800-volt capability a headline years ago. And split-pack strategies in vehicles like the Cybertruck show how the industry is adapting to a charging world that isn't uniform yet. So this charging war didn't begin at the station. It began the moment America chose which voltage it wanted to scale, before most buyers even knew voltage was a battlefield. Here's the physics that quietly decides who wins. Charging power is basically P equals V times I. If you want 200 kilowatts of charging at 400 volts, you're asking for roughly 500 amps. Push higher 250 kilowatts, and you're flirting with 625 amps. That's not just a number. That's heat. That's thicker cables. That's stricter cooling. That's more loss in every connector and every millimeter of copper. Now flip the architecture. At 800 volts, 200 kilowatts can happen around 250 amps. Same power, half the current. Less current means less resistive heating, and the heating penalty rises brutally with current. It's why 800 volts isn't a luxury badge. It's a systems advantage. Lighter cables, less stress, and more room to sustain high power before the truck has to protect itself. And this is where the US pickup reality gets exposed. A 400-volt truck can still post a fast charging headline, especially early in a session at low battery percentage. But sustaining that power is the real battlefield. As the pack warms and the state of charge rises, the battery management system starts doing what it was designed to do: limit current to protect the cells. That's when the curve falls. That's when the driver feels betrayed. It said fast. Why is it slowing down? So the war isn't about one peak number. It's about how long you can hold meaningful power without cooking the system. And if the market is training people to expect 10 to 15-minute refuels, then architectures that reduce current stress like 800 volts or clever split-pack strategies aren't optional. They're survival. Now let's talk about the battlefield. The ads don't show the charging stop itself. Public fast chargers are not a laboratory. They're a messy negotiation between the station, the cable, the connector, the truck's pack temperature, and the battery's state of charge. That's why two drivers can pull into the same site, plug in for the same 350 kilowatt charger, and leave with two completely different experiences. This is where 400-volt trucks feel the squeeze. To reach big power at 400 volts, they rely on massive current. But high current is exactly what stations and cables struggle with heat cooling limits and hardware tolerances. When anything in that chain says no, the cable warms up, the connector gets hot, the pack temperature rises, the system defends itself by dropping power, and the driver doesn't see battery safety logic. They see a promise collapsing in real time. This is why people talk about charging like it's betrayal. First, it's fast, then it dies. That drop, often called the charging curve, becomes the emotional core of the EV truck debate. Not range, not horsepower, the curve. Because in truck culture, time is not a lifestyle issue. Time is money. Time is work. Time is whether you make it home. And if the industry is moving toward a world where 10 to 15-minute refuels become normal, then the winner won't be the truck with the biggest battery. It will be the truck that can hold serious power without the curve falling off a cliff. Here's the uncomfortable truth: voltage decides supply chains. An 800-volt class strategy isn't just about charging speed. It changes everything downstream. You can hit the same power with less current, which relaxes thermal stress. Less current can mean thinner, lighter cabling, and in a truck, weight is range. Lower current stress can reduce the need for extreme cooling at every layer. And when the system is less stressed, the charging curve has a better chance of staying flat longer. That's why 800 volts starts behaving like an industrial moat. Because once a platform is designed around higher voltage, you're not just selling a truck. You're selling a future ecosystem: chargers that can deliver stable power components, that can handle it efficiently, and batteries engineered to accept it without panic. Now watch how companies quietly adapt when the infrastructure isn't uniform yet. Some go full 800 volts. Others use split pack or reconfiguration strategies, essentially reshaping the battery internally, so it can play nicer with both 400 volts and 800 volts chargers. It's not marketing, it's a survival hack in a transitional era. And this is where the US market faces a strategic fork. America can keep scaling 400V pickups and hope software and stations solve the physics. Or it can treat voltage architecture as a national competitiveness issue, because the winner of fast refuel EV trucks won't just win sales. They'll win the rules of the road. Here's the trap: the US built EV pickups for the world Americans used to live in, not the world they're about to demand. A 400-volt truck can be brilliant for daily life. It can be cheaper to build, easier to source, easier to service, and perfectly fine for home charging. The problem begins when the market's expectations shift from "I can charge overnight" to "I can refuel on the road like gas." That's when 400 volts turns into a negotiation with limits. Not because the truck is bad, but because the entire ecosystem has to work harder, higher current, thicker cables, more heat management, more throttling risk, and more variability from station to station. And truck buyers hate variability. A contractor doesn't want a charging adventure. They want predictability. They want a schedule. They want a machine that behaves the same way every time, even when it's cold, even when it's towing, even when the station is crowded. This is why voltage architecture becomes culture war fuel. Because one side hears you're saying my truck is obsolete. The other side hears you're selling me yesterday's tech at tomorrow's price. And the scariest part: the longer the US stays comfortable with 400-volt pickup, scaling the more the global definition of fast refuel may move beyond what those trucks can comfortably sustain without expensive workarounds. So the question isn't, can 400 volts work? It's, can it win? Once 10 to 15-minute refuels become the expectation, not the exceptions. This is where the story gets dangerous, because America already has proof of concept inside its own borders. The Cybertruck is the awkward clue nobody wants to admit out loud. Tesla went with a nominal 800-volt class pack, then built in ways to reconfigure so it can still play with a charging world that's not fully 800 volts everywhere yet. That's not a cool trick. That's a strategic confession. It says, we know the future is higher voltage, but the present is messy, so we'll engineer around the chaos. And that's exactly the gap legacy automakers are trapped inside. If you go all in on 800 volts, you take on new complexity, new validation, new supplier demands, and new cost questions. If you stay 400 volts, you can scale faster today, but you risk training customers on a charging reality that will feel outdated the moment infrastructure chemistry and expectations jump. So Tesla's approach becomes the nightmare mirror for the US pickup market. It's not asking which truck is better. It's asking which architecture is future-proof when the rules of charging change under your feet. Because once 800 volts behavior becomes normal, the market won't forgive almost fast. It will punish inconsistency and reward the platform that makes speed feel effortless. So what happens next? The charging war doesn't end with a better plug. It ends when the market decides what normal feels like. Scenario 1. The 400-volt patch era. Most likely short-term. Legacy brands keep scaling 400-volt trucks, then fight physics with workarounds, heavier, cooling smarter, preconditioning improved software, and more robust stations. Charging improves, but inconsistency remains the villain. Some customers accept it. Truck culture doesn't. Scenario 2. The split pack bridge. The transitional winner. Automakers quietly adopt reconfigurable packs or hybrid voltage behavior so they can deliver high voltage charging without rewriting everything overnight. This becomes the survival architecture that buys time while supplier stations and battery chemistry catch up. Scenario 3. The 800-volt reset. The long-term battlefield. Once customers taste consistent 10 to 15-minute refuels, the market flips. 800-volt class platforms stop being premium. They become the baseline for serious road trip trucks, fleet use, and long-haul expectations. At that point, 400 V-only strategies start to look like the last generation of a fading system. And here's the real American risk. If the US treats this as a marketing problem instead of an engineering strategy, it could lose the narrative and the standard of what an electric truck is supposed to be. Because in the end, people don't remember voltage numbers. They remember one feeling. Did the truck waste my time? Or did it set me free? This is the biggest deception in the charging war. The number on the sign is not the number you live with. A 350 kilowatt charger is a ceiling, a theoretical maximum, a headline. But drivers don't experience ceilings, they experience time. And time is shaped by one thing that almost never makes the brochure: average charging power over the entire session. That's why two trucks can both claim fast charging and one still feels painfully slow. Because one spikes high for a few minutes, then collapses. The other never hits the crazy peak, but holds strong power longer and ends up finishing sooner. Here's the dirty secret. A charging curve that looks impressive at 10 to 20 means almost nothing if it falls hard by 40 to 60, the exact zone where real road trips actually live. That's where you stop at a station, not to top off, but to get back on the highway with confidence. So when people say, this truck charges at 250 kilowatts, the only honest question is for how long, under what conditions, and what's the average from 10 to 80? Because in the end, peak is marketing, average is reality. If America wants electric trucks to feel like freedom, not compromise, then it needs a plan that treats charging like strategy, not vibes. Step 1. Stop selling peak numbers. Start standardizing 10 to 80 time. Make the market speak one language: how fast a truck actually returns you to the road. Step 2. Engineer for sustained power, not first-minute glory. Thermal management, pack design, and cell selection should be judged by curve stability, especially under cold towing and real highway use. Step 3. Build a voltage bridge. If full 800 volts resets take time, adopt split pack or reconfigurable architectures that can thrive in both 400 volts and 800 volts charging realities without punishing the customer. Step 4. Upgrade the charging chain, not just the station count. Cables, connectors, cooling up time, and power delivery quality matter as much as the number of chargers on a map. Step 5. Tell the truth culturally. Truck buyers don't want hype. They want predictability. The winner in America won't be the loudest brand. It will be the one that makes charging boring, and boring is the highest form of trust. Because this war isn't really about volts. It's about whether America can deliver an electric truck that feels like the thing it replaced a machine that never asks permission from the road. So here's the uncomfortable ending. America didn't lose the EV truck race because it can't build trucks. It may lose because it refused to admit that charging is architecture, and architecture is destiny. If the next normal becomes a consistent 10 to 15 minute refuel, then the brands that treat voltage like a strategic weapon will make the rest look stuck in slow motion. And the scary part is, the customer won't care why. They'll just remember how it felt waiting throttling uncertainty again and again. So I'm going to leave you with one question that should start a fight. Are US electric pickups failing? Or are we simply selling 400-volt trucks into an 800-volt future? Drop your answer in the comments and tell me what you drive and where you charge. Because this war isn't happening in boardrooms. It's happening at the plug. And if you want the next episode, we're going even deeper. The hidden battle between battery chemistry, cold weather towing, and why range is the wrong obsession. Subscribe because the next phase of this war is already here.